Good morning. I hope it's good morning. So, today some information concerning mineral pigments used as color for paintings in various temples of Upper Egypt, mostly, especially in Hatshepsut Temple in Deir el-Bahari. So location of area look like this, more or less, and mineral pigments I will talk about divided into two parts. First part concerns pigments used in paintings of decoration in Hatshepsut Temple, generally at various chapels, and second part concern geological survey for determination of sources of mineral pigments. In surrounding area, this means in Deir el-Bahari and accompanying wadis, as well as at other places in Egypt. So start from paintings in Hatshepsut Temple. It's example of use of various colors, green and red, reddish, yellowish, etc. So there will be presented only a few pigments, a few places of examination, because it's impossible to talk hours and hours. So we will start from turquoise color discovered on the at chapel of Amun at Hatshepsut Temple. This is sculpture of Amun. So there are traces of pigments of turquoise colored. These pigments were tested. There we see these pigments enlarged under the microscopy, and what we may say that these turquoise color constitute only about 10 up to 20% of mineral pigments of color used for painting. Rest are various ingredients, mostly calcite, mostly organic substances. So our impression that color is, for example, turquoise color, are, let's say, with small mistake, because most of this color constitute other minerals, and this turquoise color constitute mostly up to 20%. And there is examination of this turquoise color using X-ray diffractometry, and this diagram shows various minerals present in this turquoise color used at chapel of Amun. This is copper, magnesium, carbonate magnesium, mostly minerals of various minerals of copper carbonates, copper sulfates. So it means that this turquoise color is mixture of various minerals used for paintings. Under the scanning microscopy, there is the scale 20 micrometers. We are able to observe the substance, this turquoise pigment. We see that there are various grains of various shape, and chemical analysis used made using EDS method, confirm presence mostly of copper, sulfur, calcium, silica, etc. So it's evidently seen that this Turkish color used at Amun Chapel, it's mixture of various minerals. Let's go to yellow pigment. This is collected from Chapel of Hatshepsut. In debris, on debris there are traces of sculptures, traces of hieroglyphs painted, for example in red, but in yellow color. Under microscopy, scanning microscopy, we may determine that this pigment is of very fine structure, grains are very small, and using chemical analysis, because scanning microscopy is working together with chemical analyzer, we discovered silica, calcium, sulfur, aluminium, iron. So this is mixture of kind of clay minerals, silica, aluminium, calcium, and of course there are traces of carbonates. This color, this yellow color, was analyzed using infrared spectrometry, and there is the curve of infrared spectrometry, and it's confirming that yellow color there is kind of clay minerals and traces of organic compounds at this range, this region. Next, fragment of blocks painted in red color, for example like this. It's reddish, it's sometimes mixed with brownish, but this sample was taken for analysis, and using microanalyzer chemical method, we discover that of course this red color is mostly composed of iron minerals. Iron is dominating, but we have calcium, we have disseminated grains of other elements. You see there are from surface of this red color were taken analysis, and there are the main components of this red component. Blue color was taken at the top of Hatshepsut Chapel, and there is marked place where it was. Roof is painted, top is painted in blue, but this blue is of various shadows, dark blue, light blue, and stars are in yellow color painted. So this blue under the microanalyzer confirmed that it's composition mostly of minerals containing copper and silica, disseminated admixture of other elements. Enlarged this 20 micrometers structure of this blue look like this. Of course, there's a mixture of organic matter keeping all these components together. And black color is coating many places of many painted places, But the analysis of this black color, this is scanning microscopy photograph, the scale, so the grains are very small. This examination together with chemistry, chemical analysis, confirmed that main component is carbon. So this black color is of organic origin, and its type is rest of shot, probably because of it was obtained by the way of burning of wood. And white color was tested at many places. Grains are of this shape, this light, and it's mixed with clay minerals and other. There is the scale, and chemical composition is various. Sometimes it's calcium, it's probably calcium carbonate. At other places it's silica, aluminium, and other components, probably clay minerals, probably kaolinite, etc. So there are various kinds of white pigments, white minerals used for preparation of pigments for paintings. What is interesting that most of grains of all these colors we determine, all grains are crushed. They are of not rounded shape. They are crushed. The grains are very sharp. Because during grinding, if one grind these minerals, they will lose color. Because of grinding, the atomic structure of color minerals is damaged, and this is later observed as completely other color, or even these pigments lose the color. It's completely gray or of other shape, but not real color. And there is the list of minerals determined on various objects, painted objects in Hatshepsut Temple, general temple, but at various chapels at various places. Going around the area near the Bahari and surrounding wadis, was done survey for determination, for discovery of pigments, of color pigments, and especially were tested Esna shells, system of sediments present under Theban limestone. There are arrows show the outcrop of these Esna shells, and at these Esna shells were discovered concretions of various colors, mostly red, brown, black, near black, manganese minerals, and yellow. All these local minerals were examined mineralogically. They make forms like these. There is external part of concretion built mostly of hematite. This is mixture of hematite and other minerals of iron, but minerals of manganese too, and were examined these various mineral pigments, local, discovered in Esna shells, were examined using X-ray diffractometry. And there is, for example, brown mineral with red shade, and what we have, there is dominating is anhydrite, is hematite. This is this peak, and it's accompanying with anhydrite quartz, basanite, semi-hydrated sulfur of calcium, and goethite. Next, dark brown mineral discovered in Esna shells. Dominating is again hematite, but we have glauberite, for example. This is sulfate of sodium and calcium, anhydrite quartz, natron, there are traces of natron, basanite, and goethite. Red, typical red used for painting, for example, of bodies of sculptures in tombs and in chapels, in temples, etc. It's again mostly hematite, accompanying with natriarosite. It's kind of sulfate, yellowish colored, gypsum, and other. As you see, there is plenty of minerals present in Esna shells in these small concretions, and these red concretions, composed mostly of hematite, were explored a long time during a lot of dynasties, and it was taken, this red hematite used for paintings was collected from Esna shells. And again we have orange mineral, yellowish, and there is a group of natriarosite, this is chemical formula, accompanying with basanite, quartz, and traces of anhydrite. Yellow mineral dominating is natriarosite in Esna shells. There is mineral composition. Accompanying there are sulfates, there is quartz, and sometimes other admixture. But this is the main dominating composition of yellow concretions. After collectioning of these various minerals from Esna shells, we did a mixture of various minerals, and we tried to make pigments using various minerals and various mixtures containing various amount of minerals, local minerals discovered in Esna shells. And as you see, 1, 2, 3, 4, 5, 6, there are examples of colors made, 1 using goethite, 2 using goethite, as you see, slightly darker, 3 hematite, pure hematite and goethite 50-50, it's number 4. Goethite 80%, calcite 20%, it's 5. And natriarosite, yellow, made using local minerals from Esna shells, is look like this. In summary, we may say that at the region of Deir el-Bahari, in Esna shells, but in Theban limestones, kind of veins, there are present various minerals were determined: hematite, goethite, anhydrite, sulfur, calcium sulfate, basanite, and gypsum, crystalline. After grinding white, baryte was determined, not too much, but sometimes is mixed with gypsum, and after grinding is impossible to determine macroscopically what is the main component. Glauberite, this is sulfate of calcium and sodium. Natriarosite, sulfate of natrium containing fluorium, etc., and quartz, which is white or translucent, various shadows. And there is description of details concerning local minerals near Deir el-Bahari, discovered during geological survey. Because not all minerals were discovered in Esna shells, we did survey at Sinai, looking for old mines, digging, exploring various minerals. Between these minerals we discover near north from Santa Catarina, we discovered traces of dynastic mine exploring turquoise. These turquoise, there are relics of turquoise, but when we look more closer, we discovered small pieces of turquoise. This region we did examination is more or less there. Land photo of landscape look like this. Area of presence of old mines. There are small hills and small trenches, very strongly damaged, very difficult for determination. There are more or less at this area. And we discovered, we believed, when we find this, we believe that there are turquoise, but we took samples to Poland for analysis under the microscopy, polarizing light microscopy. This turquoise look like this. It's seen that it's various crystallinity, various transparency, various turquoise color, one time more green, one time more blue. It's there is a mixture of azurite, carbonate of copper. There is a mixture of or intercalation of flake minerals, group of muscovite, and there are chemical analysis of this material from Sinai, and it's well seen that this material is differentiated chemically, because sometimes 30% of copper, sometimes 11%, other places 35%. There is various admixture of other elements. So this mineral we discovered in Sinai, it's a mixture of various minerals of copper, but other elements are of course present too. Generally this turquoise, so-called turquoise, this green-blue mineral from Sinai is chemically and starting and looking from point of view of crystallinity, etc., very similar to mineral used for painting of face of Amun in Amun chapel in Deir el-Bahari. It's not exactly probably place from where this mineral was collected, but at this area in Sinai there is plenty of various old mines, probably at other places was collected and used for paintings in chapel of Amun at Hatshepsut Temple at Upper Egypt. So we discovered some local minerals used for painting as pigments. We discovered this mixture of turquoise color minerals in Sinai, but some other are not known from where they are. blue in chapel of Hatshepsut was determined mostly azurite, copper carbonate, but probably was used lapis lazuli, which was very expensive at this time, dynastic time. Material was probably from Sinai and lapis lazuli from Afghanistan. Turquoise color we discovered in Sinai probably was collected for paintings from this area. Green mineral, malachite, copper carbonate. Now we didn't discover in Sinai and in region of Deir el-Bahari, but probably there are places in East Desert in Egypt where malachite is present, green copper carbonate. Maybe it was imported from region of Wadi Fayran, where at this time were great mines exploring copper, and other places are for determination for next scientist working in pigments. So this is conclusion concerning turquoise color from Amon Chapel that is probably, in probability is great, it's from Sinai. So thank you very much for listening. This is table prepared for meal in Polish house in Deir el-Bahari in Egypt. Thank you very much.